Okay, so here are just a couple brief example problems to demonstrate the typical multiplication and exponentiation problems that we will run across. So, find a modulo for residues of each of the following. 17 times 18. Well, 17, and I get modulo for residues just means find the remainder when divided with 4. 17 divided with 4 has a remainder of 1 because 4 times 4 is 16 plus 1 is 17. So 17 becomes 1. 18, therefore, since it's 1 plus 17 is going to have a remainder of 2, which is congruent to, 1 times 2 is 2, and mod 4. So our answer is that the modulo for residue of 17 times 18 is 2 mod 4. Which, also tells us that, 17 times 18 is 306. So that, is also just 2 mod 4 as well. Same residue class. Okay. Now we have 523 times 421. Well, if you think about 523 divided by 4, goes in once, subtraction with a 1, drag down to 2, goes in 3 times, which is a 12, drop the 3, goes in 0 times with a remainder of 3. So 523 mod 4 is congruent to 3. Now 421 mod 4, 4 divided by 4. This one we can. Alright, let's try this one in our head real quick, right? 400 is 4 times 100. 20 is 4 times 5. Therefore, 205 times 4 is 420. Now, since it's 421, then what that means is... Oh, wait, what did I say? No. Yeah, it's not... No, it's 105 times 4 is 420. So therefore, to get to 421, we would have to add 1 as our remainder. So 421 has that remainder of 1 when divided with 4. Then that is congruent to, 3 times 1 is 3. Then we have mod 4. And again, this also establishes the fact that 5,023 times 421, this huge number 220,183 is congruent to 3 mod 4. Not an essential part of the problem, but just to help us conceptualize all the things we can learn from this process. Alright, 15 to the 15th power, mod 4. Well, your instinct might be to go, alright, 15 divided with 4, that's going to be 3 with a remainder of 3. So we could do 3 raised to the 15th power. Right? And that's okay. But 3 to the 15th power, it's it's a little much to deal with. So what I could do is thinking of like that the circular system of modulo. So modulo 4 has values 0, 1, 2, and 3. Where, you know, a positive 3 is the same thing as a negative 1. Remember, when I go counterclockwise, it counts as a negative. You could also think of it as 4 times 4 is 6 with a remainder of negative 1, you know, in a weird way. So I could just convert this to negative 1 to the 15th power. Since it's an odd exponent, that means it's still just going to be negative 1. And we have already established that negative 1 is congruent to, well, negative 1 is congruent to, in the positive direction, 3 under mod 4. So 15 to the 15th power is the same as 3 mod 4. Okay. Now we have these values. 121 times 122 times 123. Mod 4. Okay. Well, I noticed that they're just in an increasing order by 1 each time. And I know that 120 must be divisible with 4. In fact, it's just 4 times 30. Plus 1, of course. So 121 has a remainder of 1 mod 4. And therefore, since we're just increasing by 1 for 122, it's going to have a remainder of 2. And since 122 is increasing by 1, that remainder is going to be a 3. Until we'd hit 124 again, which would have a remainder of 0. But this is easy to work with. So 1 times 2 times 3 is just 6, which is congruent to 2 under mod 4. And if we really cared, 121 times 122 times 123 is like a million something. So 1,815,726 is congruent to 2 mod 4. So these are some nice, easy, basic examples of problems involving multiplication and exponentiation.